Kamal. Today we are going to learn something about this different LR parsers. We have already seen something about LR0 parsers. So in last video we have seen how to construct LR0 parsing table as well as LR parsing algorithm. The parsing algorithm will be common for all the parsing all the LR parsers, whether it is simple LR or canonical LR or look ahead LR. So now what you have to see is a little difference between these parsers, which is only related to the construction of parsing table. So what happens in simple LR? Basically, the reduce in tree, as you have seen earlier, the reduce in tree was in all the three columns, right? Basically, let me tell you again, in LR0 parsers, the parsing table construction was like that, where in each column you were writing each column. In columns you have these terminals. So whenever there is a reduce entry, this entry is kept in all the columns of terminals. So now here in case of simple LR, we are keeping this reduce entry only in the follow of reduce entry is kept in follow of the non-terminal or variable, whatever you say. Now, why are we going for this thing? Why do we want this reduce entry not to keep in all the columns and to keep in only the follow of the non-terminal? You may remember that reduce entry is only for reduce entry shows that which particular production is reducing. It may be alpha derives beta, right? So we are calling this alpha as non-terminal. So we keep the reduce entry for this production in the follow of alpha. Okay. So why we are going to do this? This is because sometimes in LR0 parsers you would have seen when we are keeping this reduce entry in all the columns in corresponding to all the different particular terminals. So what happened in that case, in particular some of the cells you will have both reduce and shift entries. Okay, that will create a conflict. You can call it as a shift reduce conflict. So there may be certain states. Those states which are creating conflict, they will be called as inadequate or inadequative states. And sometimes you get such questions: what is inadequative? Inadequative state. Basically, it is a state which are creating conflict. So the conflicts can be, let me say, shift conflict is not possible. Shift reduce or reduce conflicts can be possible. Okay, conflicts can be either shift reduce or reduce. This is shift reduce and this is reduce. So in a particular cell, if you have two reduce entries or one shift and one reduce entries, that is creating some conflict. Okay, so you should understand that shift entry is not possible. In one cell you will not have two shift entries. Okay, this is because we have deterministic finite automaton, right? DFA. So there are two shift entries. Now I was telling you about how simple LR is different from LR0 parsers. The only difference is this reduce entry is not kept in all the columns. It is kept in particular columns, those columns which correspond to the follow of this non-terminal. Okay. Now there is something called canonical LR, right? Canonical LR. How is it different? In canonical LR, basically you will have LR1 items. In place of LR0 item, you will have LR1 items. LR1 items. With this LR1 item, actually you will see, okay, let me tell here only that what are LR1 items. Actually what happens, it is just, I should say, LR0 items plus one look ahead symbol. This is only the thing which makes it different. One look ahead symbol with all the items. Earlier you have seen what items are, where you remember these things, right? So what happens to items? You just have this thing with a dot, right? Now in LR1 item, what will happen? You will have the same thing. Maybe you will have one extra symbol along with that. So let me keep it here. It is like S gives AA, it was, you kept it like this, right? Along with this you will also keep one extra symbol. Maybe for this it is dollar, maybe for others, suppose these are all LR1 items. Okay, so you have also to learn how to find closure of these LR1 items. These are the two things you will have to see for CLR parsers, right? So rest of the things are same. One more difference here will be that this reduce entry will be kept in this look ahead symbol. This look ahead symbol is being carried out with this item. This is only for this purpose, that this particular reduce entry has to be kept in this particular thing. Okay, so that is very simple. Now I will tell you something about how to find closure of this thing, right? We can find the closure of LR1 item. Let me write it here. How to find closure of, we will again come for LALR. Let me tell you about closure of item I. You remember we have already seen closure of So the same thing, we will add this item I to the closure of I. Add the item I in closure of I. Now in second step, you will see if this item I is like something alpha derives something, suppose A dot B beta. If this, okay, along with this you will have some symbol, right? Let me write down. So if this is your item I, then you will also have to consider what is this B. B is a symbol, right? Non-terminal. So what is this B? Suppose B is something. B derives something A and B. So this is also present in grammar. This is element of grammar G. If it is true, then what you are going to do? You will add this B derives AB, and here what you are going to write? You will write the first of this thing. What is it? So you will find the first from this, and then you will add this to the closure of I. Now in third step, what you are going to do? You will repeat this step. Repeat the step 2 for every newly added item. Okay, so that is very simple. You will find out these things. These look at symbols will be used for reduce entry. So that is how very simple thing you are going to do here. So till now you have seen that SLR was different from this thing. LR. Reduce entry was only in this thing, the follow of non-terminal. Here in both of these CLR and LALR, the reduce entry will be in look ahead symbol. You will always have a look ahead symbol with this. The only thing is here you are using your canonical LR, you are using LR1 items. Okay. However, in LALR1 item, in LALR method, basically, it will be based on LR0 set of items. And in comparison of LR1, this LALR will have less number of states. Maybe it will have similar number of states to simple LR. Okay. So what happens in LALR? You will have LR0 item with a look ahead symbol, right? However, you will not have to define like this. You will not have to find, I should say, the closure of LR1 item. In place of, the closures will be found for the LR0 items. Okay. So in this way, the LALR parsers, whatever you will get at table, will be same length as it is for SLR. So if we try to find out which are more powerful, in that case we will find that CLR parsers are more powerful than others. However, LALR can be in between SLR and CLR. SLR is definitely powerful than LR0. Okay? Or somehow you can assume LR0 and SLR have similar power. Okay? At least the number of states are same. And number of states are also same for LALR. However, for number of states will be more for CLR parsers. So these are few things you can understand. If we think about shift entry also and reduce entries, so you have seen that shift entries are similar for all, reduce entries are only which are changing for all the parsers, right? Now if you think about some more things. Suppose this is your LL0 parsers. Okay, so you should understand that LL1 parsers will be more powerful than LL0 parsers. Similarly, LL2 will be more powerful than your LL1 and so on till suppose you have something LLK parser. So it is more powerful than any LL0 parser or any LLK minus something parser. Okay. Similarly, in case of LR parsers also, if I tell you about if K is increasing, it is okay. If it is K is 1 only, okay, you can understand that we have seen LR0, SLR, LALR and CLR. So in that particular order, you can understand that this particular LR0 is less powerful, LR0. And there will be SLR, this is a little more powerful than LR0. Powerful means some of the grammars which can be parsed by SLR. Another thing is LALR parsers. Then in outer layer I should write CLR. Now if these are some certain parsers and if we have to compare these with LL parsers, so let me tell you that this particular range, the LL1 parsers can be in this range, which means LL1 can be equated with LR0, SLR1 or LLR1. However, CLR1 is definitely more powerful than LR1. But you can understand that it is always working on unambiguous grammar. Okay, so it is always working on unambiguous grammar. Okay, now there are certain grammar which will be ambiguous. Okay, so let me assume these are ambiguous grammar. So these CLR are not able to parse ambiguous grammars. However, there are certain grammar, I should say the parsers you have seen. Which parsers are able to parse the ambiguous grammar? They are operator precedence grammars, right? So let me say that operator precedence parsers will be able to, these are unambiguous, no? So some ambiguous and some unambiguous grammars, right? Let me write it: operator precedence parser. Okay, operator precedence parsers. Yeah. So in this way it is working. One thing that you should understand, in most of the case when we talk about LR, you should assume that we are referring to CLR. Okay, if at all we are referring LR0, then it is LR0, or SLR or LALR1, then they are different. If we are not saying anything, in that case, if we are saying just LR, we should assume we are talking about CLR. Okay, now these LR parsers were a type of bottom-up parsers. So in this bottom-up parsers, it is difficult to design. Why? Because we have to construct DFA, right? In case of top-down parser, it was easier because we didn't have to create DFA kind of thing, right? Just recursive, one table is there, okay, no problem. Now, actually we had a table there in top-down parser. Now also we have a table here in bottom-up parser. What can we think about the size of these two parsers? So usually if we will see the size of this bottom-up parsers are size of these tables of bottom-up parsers are more than the size of top-down parsers. Actually it may be around twice the size of top-down parsers. So these are few things that we should understand if you understand about these conflicts. Now there is something called CLR, LALR. So there, if for same grammar you have a CLR and there you don't have any conflict, but still a kind of conflict may be possible in LALR. Okay, it will be reduce conflict. Okay, these are certain type of questions which usually being asked. Something like whether this SR conflict is possible in CLR or not, kind of thing. So it is possible, but if there is no shift reduce conflict in CLR, then shift reduce conflict is not possible in LALR. That is the thing. But in the case of reduce conflict, it is possible. Even though in CLR it was not present, but it may be present in LALR. So that is a few things that you should know about parsers. In this way we will complete these talks on parser. More details, definitely you should visit this book on and go through these parsers, and then we will start